So we are working on practice problems for Chapter 13b. We'll get right into it. Question 1. Your portfolio is invested in 25% in stock X, 30% in stock Y, 40% in stock Z, and 5% in stock W. The expected returns on these stocks are 10%, 15%, 6%, and 16% respectively. What is the expected return on your portfolio? It gives us a hint, lets us know the expected value of a portfolio return is the weighted average expected return of the components comprising the whole portfolio. And we're told to round our answer to 3 decimal places. So I'm just going to make a little table here of the stocks and their returns and our weights within those stocks. Okay, so right now I just created a table of just all the given information, put it in a table that way it might be a little bit easier to see kind of what we're doing here. Hopefully everything I have written down here makes sense. And then I'll just go ahead and calculate the expected return. Expected return is equal to the weight in stock X times the return of stock X plus the weight in stock Y times the return of stock Y plus the weight in stock C plus the return of stock C plus finally the weight of stock W times the return of stock W. And we get 10.2%. All right, question 2. All right, so we are using this stock data right here for the next 2 questions, and we have to assume that future return data will be similar to the historical data. So if we look at question 2, it's asking for the expected value return for a portfolio constructed of 50% of stock A and 50% of stock B. Question 3 is going to ask us about the exact same portfolio, constructed 50% of stock A, 50% of stock B, but it's asking for standard deviation. So we're going to solve these two kind of hand in hand. I'm just going to go ahead and copy and paste like what our expected value return formula is for a portfolio comprised of 2 stocks. I'll put it right here just so that we know what we're doing. And I'll go ahead and do the same thing for question 3. That way we also have that formula down here. Again, these are directly from the notes, and they are the average of a portfolio comprised of 2 stocks and the standard deviation of a portfolio comprised of 2 stocks. So we look at question 2, it's just the average. So the average is equal to the weight in one stock times the return of that stock plus the weight of the other stock times the return of that stock. So we can do a similar thing here for 2 that we did for question 1. We can put down what stock we have, what the return was, and what that weight was. If we go ahead and find that expected return, we'll take the weight of stock A times the return of stock A plus the weight of stock B times the return of stock B. All right, and we get 11%, and that's the correct answer. So we'll go ahead and move forward to question 3, where we're solving for the standard deviation of these stocks. So to start off with question 3, I'm going to do a very similar thing to what I did for question 2. I'm just going to create a little table with the needed information. So look at this formula. We need to know which stock it is, the standard deviation of that stock, the weight in that stock, and we're also going to need the correlation coefficient. All right, and now that we have all the information, what let's do is now put all these numbers into our equation, and we'll go ahead and get that answer. I'm going to just solve this as a 2-step problem. So I'm going to solve for the standard deviation squared, and then I'm going to go ahead and find out what the actual standard deviation is. Or in other words, I'm just going to solve for the variance first, which is the standard deviation squared, and then solve for the standard deviation. Sigma squared is going to equal the weight of stock A squared times the standard deviation of stock A squared plus the same thing for stock B, so the weight of stock B times the standard deviation of stock B plus 2 times the weight of stock A times the weight of stock B times the standard deviation of stock A times the standard deviation of stock B times rho, or the correlation between stocks A and B. All right, and that's our sigma squared, or our variance. And so then to actually get our sigma, or our standard deviation, of the returns for the entire portfolio that you're going to construct here, we're just going to take this, and in Excel, we're just going to put it to the power of 0.5. Alternatively, I could have gone ahead and done equals square roots of this number, and we're going to get the exact same number. And sigma for question 3 is 0.176, or 17.7%. All right, so we're going to go ahead and move on to questions 4 and 5. These questions are going to look very similar to questions 2 and 3. As we are calculating the expected value of a portfolio construction of 2 stocks and the standard deviation of that same portfolio. The only difference here is the stock data that we're given, and the weights of our portfolio is different. So it's not going to be 50% in each stock. It's going to be 30% in stock A and 70% in stock B. I went ahead and put in our little equations here for calculating the mean and standard deviation of a portfolio with 2 stocks. And I'm just going to go ahead and calculate those. All right, so if we're looking for expected return of 2 stocks, we go ahead and take the weight of stock A times the expected return of stock A plus the weight of stock B, which is 0.7, times the expected return of stock B. All right, and we get 0.115 or 11.5%. And then if we go ahead and do the exact same thing for standard deviation, I'm just going to solve for sigma squared first, and then I'm going to solve for sigma. As we solve for sigma squared, we're going to have to take the weight of stock A, which is 0.3, square it, times the standard deviation of stock A, in other words, the sigma of stock A, plus the weight of stock B squared, times the sigma of stock B squared, plus 2 times the weight of stock A, times the weight of stock B, times the standard deviation of stock A, times the standard deviation of stock B, times the correlation between stocks A and B, or in other words, rho. All right, and our variance for this portfolio is 0.0315. And if we just go ahead and find sigma, which is just the square root of our variance, we find our standard deviation of returns for this portfolio is 0.177. All right, so moving on to the next sheet of the practice problems for Chapter 13b. This problem was going to help us kind of understand beta, maybe just a little bit more. Due to disruption in the screen-based entertainment industry and the Walt Disney Company's response to it, you believe that only the past several years of Disney stock performance are indicative of its future prospects. With this in mind, compute Disney's beta using the stock price information provided below. Assume the SPY ETF is a decent measure of the overall stock market. Do not round intermediate calculations. Compute your answer to 3 decimal places. Do not represent your answer as a percentage. Okay, so just stopping reading that question right there. What this is saying is that Disney, stock ticker DIS, has been a publicly traded company for years and years and years. But you, based on current market conditions and kind of what it says here in this first sentence, you believe that all the historical data is not going to help us predict anything in the future expected returns or expected standard deviation. You only think that the past few years are going to help us do this. So this first paragraph just builds your assumption before going in and solving the problem and looking at the data. So I think that's just an important thing to understand, is that typically you want to have more data rather than less data, but if you believe that more data is not going to help us understand the future performance of Disney stock, then you're not going to use it. All right, so continuing. So in general, we're trying to figure out how is Disney performing compared to the stock market, and what can we kind of expect here going forward as far as volatility goes and our expected returns. All right, and then he starts us off with a hint. He says, first compute the returns of SPY and Disney for years 2001 through 2005. So that's exactly what we'll go ahead and do. So solve for the return within a year. You take the new value minus the old value, or in other words, you take the difference, and you put that change all over the old price. So the change from 2010 to 2011 was only 2.7%. All right, and all we have to do is remember that these are returns for the whole market, and this is a return for Disney. All right, and then it says, then either A, compute the standard deviations of each stock, the correlation coefficient, and finally the beta of Disney to SPY using the correlation coefficient and standard deviations, or use Excel's data analysis regression tool to compute beta directly from the returns. I will go ahead and do both options. So if we do option A, we go ahead and solve for standard deviation of the total market and standard deviation of Disney. And since we're using Excel, I can go ahead and just use Excel's functions. When solving for standard deviation, you go ahead and use this stdev.s. This S is just telling us that it is standard deviation of a sample, because this is a sample of data. This is not the whole population of data. Standard deviation of this range. And we'll do the exact same thing for Disney. All right, and to find that correlation coefficient or to find rho, the Excel function is just correl. So you're trying to figure out. And because I typed it in the way I did, this is correlation coefficient of the total market to the stock. We go ahead and take rho times the standard deviation of Disney divided by standard deviation of the total market. All right, and that's our beta for Disney to the total market. So what this beta is telling us is that Disney is a little bit less volatile than the market. So what this can tell us is that as an investor, if we are deciding between putting money within the total market through an investment vehicle like a ETF, or we're looking at putting money in an individual stock like Disney, we are willing to accept a low return on the individual stock. All right, and if we're looking at option B, we are going to go up into the Data tab of Excel. And we're going to look along this ribbon, and to the very far right, we should see a data analysis button. If we don't see a data analysis button, then we have to go into File, hit Excel Options, and go ahead and add data analysis as a tool in Excel. If you don't know how to do that, go ahead and just Google Excel data analysis tool add. And that should give you a step-by-step of how to put that on your ribbon of tools. When I click data analysis, this box is going to pop up. Allows me to do a bunch of different things. So if I go ahead and hit regression, then I can run regression. And if I go ahead and say that I want my Y's to be the returns of Disney, I want that to be relative to my X's, which would be the returns of the total stock market. And I'm not checking off labels or anything because all of our numbers are numeric. There's no label. And I want to just go ahead and kind of put my results down here. I don't want Excel to create a new worksheet for me. And then there should be no need to check any other boxes. And so this is our output when we go ahead and go through those steps. Excel gives you a lot of information, a lot of stuff that you might have seen in a prior statistics course or you might take in a future one. If you don't know what most of this means, that's okay. This was just a run through of an option that Excel allows you to do. And where beta is on this whole thing, beta is going to be the slope, or it's going to be the regressed x variable. So it's going to be right here, 0.7839, and that's the exact value that we have right here. Everything checks out, and if this did not make sense to you, that's okay. You're not going to need to know how to do this in order to succeed in this course. However, I think it is useful and hopefully something that you will end up learning in a future course.